All right, ladies and gentlemen, and we're back. So again, we're going to jump into chapter 4. I know it seems weird that we're going into chapter 4, yet we're doing a notes on section 1-8, like chapter 1. What the heck are we doing? Well, we decided to go back and pick up section 1-8 because it's a graphing review. And guess what we're doing in chapter 4? Graphing. Okay? So that being said, make sure that every time I ask you to graph on your homework, what are you using? Graph paper. Okay? Make sure that you are using graph paper every single time I ask you to graph on your homework. Will there be graphing on tonight's homework? Yes. Should you use graph paper on tonight's homework? Yes. If you don't have some, guess what? Freegraphpaper.com. Right. There you go. Then you got some graph paper. Okay? Do that before you leave school, so don't use your own ink. I didn't say that. All right, section 1-8. Section 1-8 again is introduction into function. Introduction to function. Now, you guys have talked about this coordinate plane before, right? You guys have graphed, right? It may be very just simple, just point here, point there. Maybe connect the dots, maybe make some ordered pairs, whatever. So let's go through it from scratch. Remember that the coordinate plane is basically just two number lines. That's a number line going like this, and a number line going like this. Yeah? It is a horizontal number line combined with a vertical number line. See, chapter 3, we only talked about the horizontal number line. Chapter 4, we bring that vertical number line and gives it 2 dimensions. Yes, there is even a possibility once you get into higher level math, there is a third dimension. There is a z-axis as well that goes in and out. So, and through 0, 0. So it does give it a third dimension depth to it. But that's the way it is. But know that our coordinate plane is just two number lines. They cross at 0, 0. That's known as the origin point. We have the x-axis and the y-axis. The x-axis is the horizontal number line, and the y-axis is the vertical number line. We have the quadrants named going from top right counterclockwise around. Quadrant 1, 2, 3, and 4, usually written as Roman numerals. Quadrant 1, 2, 3, and 4. But if you gave me the number, I really wouldn't care. Okay. The ordered pairs that I was talking about, ordered pairs, those are just the combination of input and output. The combination of x to y. If x is this, then y is this. Okay? That's an ordered pair. The x moves the point left and right. The y moves the point up and down. So if I've got the point 5, 7, I'm going to move right 5, up 7, and make my dot. Negatives in the x is going to move it to the left. Negative in the y is going to move it down. We have our quadrants here again. I talked about them a little bit. One special note here is that if it is not within a quadrant, if it's lying on an axis, then you just say it's not in any quadrant. It's just lying on that axis, and you'll see what I mean here in a second. So do this with me. Just let's go back to basics. Let's just plot some points. Make sure we know what we're doing here. Okay. We got 3, 2. 3, 2. Make sure your coordinate is right there. Now, it's denoted by the letter A, so I'll put a little A right there, usually denoted by a capital letter. Please know that it is not, I'll put it in purple so it's weird, it's not there. That is the point 2, 3. Remember, you go left, right, then up and down. Okay. So that is point A. Let's plot them all and then talk about what axis or what quadrant it's on. Point B is -4, so that means I go to the left 4, and then +1. That means up 1. There's point B. Point C, right, right 2, down 5. Right 2, down 5. There's point C. Point D is at 0, 0 left and right, and then up 3. There's point D. And then we have point E, -3, 0. Left 3, and then 0 up and down. How did we do on plotting those points? We do okay? Usually the ones that throw people off are those coordinates. And usually those are the ones that throw people off. Did anybody know what fancy name that we can call those coordinates? Where it crosses the x or y axis? $10 word today. The intercepts. Yeah, do you remember that word? The intercepts. The y-intercept, the x-intercept. Okay, let's name the quadrant that it's in. Where is point A? Quadrant what? 1. Where is point B? 2. Where is point C? 4. Where is point D? None. It's on the y-axis. You would write y-axis. Where is point E? On the x-axis. If it's lying on an axis, it's not in a quadrant. It's on the axis. Okay? Be careful with that. All right. So how do we generate ordered pairs? Well, we generate ordered pairs with an equation, right? With an equation. We talked about creating these equations a lot within chapters 2 and 3. Okay, if you can create an equation, then you can plug in values into that equation. It's going to give you an input. It's going to give you an output, right? Input and output. I could plug in 1, I would get 15. I could plug in 2, I would get 25. I would plug in 3, I would get 35. Plug in 4, I get 45. And that process could continue forever, right? Could I plug in 0? Sure. Could I plug in negatives? Sure. -1, that's going to give me a -5. -2, it's going to be -15, and so on and so forth. Every input is going to have a matching output value. And that's creating ordered pairs. That's creating ordered pairs. Okay, so let's do this word problem here. An engraver charges a setup fee of $10 plus $2 for every word engraved. Write a rule for the engraver's fee, and then write ordered pairs for the engraver's fee when it's 5, 10, 15, and 20 words. And then we're going to graph too. Notice that there's a graph there. It doesn't tell us the graph, but we're going to. Now, what's on my screen that's not on your guided notes? What's on my screen that's not on your guided notes? The t-chart, right? Draw that in. Whenever I ask you to plot points or make some ordered pairs from an equation, I want you to make a t-chart for now. Later on, we won't have to do that, but for now, let's do that. Let's start off by writing an equation to represent the scenario. I mean, I can tell it from the first line. What's my equation? It's a $10 startup fee and $2 for every word. Think? Good. Let's call it x if we're doing x and y. Y is equal to 10 plus 2x, where x is the amount of words and y is the total cost. Okay, so it says write ordered pairs for the engraver's fee. Now, again, when it says write the rule is just writing the equation. So don't let the words confuse you there. Writing a rule is writing the equation. All right, let's write the ordered pairs for 5, 10, 15, and 20. Okay, so all I have to do there is just plug in 5. Y equals 10 plus 2 times 5. Well, 2 times 5 is 10, plus 10 is 20. $20. Y is equal to 10 plus 2 times 10. $30. Y is equal to 10 plus 2 times 20. Oh, no, 15, excuse me, 15. Not to 20 yet. Well, 2 times 15 is 30, plus 10 is 40. Y is equal to 10 plus 2 times 20. 2 times 20 is 40, plus 10 is 50. Do you see how these y values are going up at a nice, even rate? That's a line. That's a linear function. Okay? All right, write ordered pairs to the following, okay, if I really want to write them as ordered pairs, it would be good to write them as coordinate form. 5, 20. I put a semicolon in between each one, just a spacer. 10, 30. 15, 40. And then 20, 50. Okay, now, you've got a graph on yours, so let's graph it. Now, I don't have a graph on mine, so I'm just going to have to make it up as I go along. Oh, I didn't even talk about it yet, but why am I only going to do the first quadrant? Why am I not using quadrants 2, 3, or 4?
Because there are no negative numbers.
Right, there's no negative numbers. I'm not going to go to the left on my x or y axis, so that knocks out quadrants 2, 3, and 4. Okay, always label your axes. Always label your axes. What is my x-axis label? What is my label on my x-axis, Dane? Words. Words engraved. What's my label on my y-axis? Owen? No, that's the x-axis. What's the label on my y-axis? Money. Now, you can do the scale however you want on yours. It looks, since I just have to create this from scratch, I'm just going to go like this. 5, 10, 15, 20. Make sure you label. And make sure it's even, too. Make sure it's even. And then we're going to say 20, 30, 40, 50. Okay, let's go by tens, I think, for mine. 10, 20, 30, 40, 50, 60. Okay, here's 10, 20, 30, 40, 50, 60. Okay, and now I plot my points. I say 5, comma 20. I say 10, comma 30, 15, comma 40, 20, comma 50. Hey guys, what would have happened if I plugged in 0? I know it doesn't make sense in the situation. Why would somebody get 0 words engraved? But what would I get if I plugged in 0? 10 plus 2 times 0 would be what? 10. Right, so that's my y-intercept point. Okay, and now I graph my line. Questions about that? Okay, let's keep it going. Now, that had context. So what do I mean when I say context? That had meaning to the numbers, right? X was the amount of words, Y was the total money, and so on. So let's take the context away and make it a kind of a weird equation and see what happens. Generate the ordered pairs using the given values for X, and then graph the ordered pairs and describe the pattern. Okay. So I've got -2, -1, 0, 1, and 2. All this is telling me, all this piece is telling me is that those are the X values that I want to plug in. I strategically gave you X values to make you see some sort of pattern. Okay? So, what do we do with -2? To find to see the Y value, what do I do with -2? Okay. Plug it into X. Be careful here. I want everybody with their calculators. Everybody get your calculators out. No exceptions. Everybody get your calculators out and plug in -2. I'm going to do a little experiment. Everybody get your calculators out and plug in -2. Plug in -2. Yeah, question, Dave. Okay. Raise your hand if you got -7. Raise your hand if you got +1. Uh-oh. Because 1 is the right answer. Uh-oh. Uh-oh. What should you get when you plug in -2 in for X? People, look at this. Y equals -2 squared minus 3. What did I do when I plugged in -2? I put in parentheses. Why? Because I'm squaring the entire -2. What happens when you square a negative number? You get a +4. 4 minus 3 is 1. Guys, watch here. Use parentheses. I will say that so many times this year. Use parentheses. Put the square on the outside of the parentheses. Okay. Since we all got it wrong, let's plug in -1. Everybody plug in -1. So you're doing the same thing. What do we get when we plug in -1? Same? -2. Good. When I plug in -1, I say parentheses, -1 squared minus 3 is -2, right? Y equals -1 squared minus 3. So let's do the same thing for 0. 0 squared minus 3. Well, what's 0 squared? Just 0, right? 0 minus 3 is -3. Now, when we start to get into positives, the parentheses don't matter in the positives, okay? They only matter in the negatives. So this is going to be the same thing. 1 squared minus 3 gets us our -2 again. Y is equal to 2 squared minus 3. 2 squared is 4 minus 3 is 1. What do we notice about our y values? What do you notice about your y values? Okay? Yeah, they're repeating themselves, aren't they? Watch what happens when it on the graph. -2 comma +1, -1 comma -2, 0 comma -3, 1 comma -2, 2 comma 1. What happens is you actually get this U shape. You remember how it said describe the pattern in the directions? The pattern is a U shape pattern. How do we know it's going to turn out to be a U shape? Because it's got this x squared. All the negatives are going to turn positive. Whenever it has an x squared, it's going to be a U shape. U shape might point up, it might point down, it might be shifted around, it might be stretched out, whatever, but it's still going to be a U shape. We're going to spend an entire chapter later on in the year on these types of equations. An entire chapter on these types of equations. They're called quadratics. Okay, let's do absolute value. Now, I'm sorry, but there is no absolute value button in your calculator. You can't, no, it doesn't work. There actually is on mine. If I go into math, and then I think it's a number. Yeah, look, absolute value. Kind of fun, right? Okay, it's telling me that I want to plug in 0, 1, 2, 3, and 4. Okay, so that means I'm going to have y equals the absolute value of 0 minus 2. Well, 0 minus 2 is -2. And the absolute value of -2 is +2. Do the same thing with 1. 1 minus 2 is -1, which turns positive. I do the same thing with 2. Absolute value of 2 minus 2 is 0. What's the absolute value of 0? Just 0, right? Let's do the same thing with 3. Now be careful here. The absolute value of 3 minus 1. 3 minus 1 is just 2. Does the absolute value turn it back negative? No, it keeps everything positive. Why did I subtract by 1? I don't know. That's weird. Weird. 1, there we go. I was going to say, that didn't turn out right. And then we do the same thing here. 3, nope. Come on now. 4 minus 2 is 2. There we go. No matter what, the absolute value of positive numbers stay positive. Okay. So I see that whole coming back around again thing on my y values. So maybe it's a U shape again. Let's see. 0, comma 2, 1, comma 1, 2, comma 0, 3, comma 1, 4, comma 2. Okay, does this look like a rounded out U shape anymore? Looks like a V, and that's what we'll call it. We'll call it a V shape, which is convenient. Convenient, no pun intended, because it's absolute value. All right. Okay, one last thing. On homeworks, sometimes you guys will graph, If you ever, everybody look up here, if you ever get a graph that looks like this, because this will happen from time to time. If you ever get a graph that looks like this, you done something wrong. Usually, you didn't use a negative, or you didn't use parentheses around a negative. You should never, ever have a shape that looks like this. Usually, that means that you didn't square your negative correctly, okay? So be careful with that. All right, let's get to section 4.1. Okay, now section 4.1 is a very theoretical, very abstract graphing relationships section. We talk about it in very weird terms, okay? Now, section 4.1, it's kicking off this graphing chapter. So let's talk about it in real life things. How do we graph relationships with real life things? For example, here, let's take this scenario. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves from that tree. Eventually, there are no more leaves. Which graph best represents the situation? Would it be graph A, graph B, or graph C? What do you think? Graph B. Why do you say graph B?
Because graph A is just going straight down, and graph A goes up, which doesn't happen to the going up, and then graph C goes down, and then goes down again.
Very good. She's taking each piece of the graph and saying, okay, this is what's happening at each piece of the graph. Like, okay, let's think about it in terms of our scenario. Now, notice what's on our axes. I've got time and the number of leaves. So as time goes on, generally what's happening to our leaves, it's going downward. Okay, so each day leaves fall from a tree, then gust of wind comes, steep downward slope, and then it gradually goes again. Take a look here. Can anybody tell me what type of scenario would match graph A? What type of scenario would match graph A? Owen? Yeah, it's spring. It's like the whole year. Springtime, leaves go up. Summertime, leaves stay on the trees. Fall, leaves fall off.
I love that.
You do. What's the best part about fall?
The weather.
The weather? You like the colder
I
weather?
really like the weather. I don't know, but it's like it's in the middle of hot and cold, so it's like a good mild.
My favorite thing about fall are the leaves. I love the leaves color. All right. The air temperature is increased steadily for several hours and then remains constant. At the end of the day, the temperature increased slightly before dropping sharply. Which graph best represents this situation?
Your attention, please. At this time, we need any 7th grader who has not had their picture taken this year or who would like a retake, please report to the main gym now. That's any 7th grader who has not had their picture taken yet this year or would like a retake, please report to the main gym now. Thank you.
Hey, what's my answer? Graph C would be the correct answer here. Graph C, in my opinion, that's the best one to choose. Okay, that's the best one that's matching the situation. Graph B doesn't make sense. It needs to, both graph A and graph B I could knock out right away because it needs to increase right off the bat. Right? Okay, we can see in example 1, those are examples of continuous graphs. Guys, if I ask you whether something is continuous, you should be able to trace along with your pencil and never have to pick up your pencil. It's a continuous line. Like, for example, if I'm talking about as time passes, continuous, that's continuous. There's no gaps or breaks. Discrete graphs are ones that have gaps or breaks. This is an example of one. Theme park attendance in particular years. So like in the year 2000, the year 2005, the year 2010, 15, 20, if I take singular amounts, if I just take observations, then those will be discrete points. Yeah, just single solitary points, gaps and breaks. Like for example, here's an example of both continuous and discrete. Say You stood next to like a wall and marked your height every year, right? Those observations are discrete points. If you graph them, you could plot those points on a graph, right? And they would be steadily going up. But if you think about your height as time goes on, that's continuous, isn't it? You're always growing, right? That's an example of continuous rather than discrete. So it depends on how you're taking the measurement. Are you thinking about it as long-term, of continuous motion, continuous time, or are you thinking about it as singular points? It depends, okay? When sketching or interpreting a graph, pay close attention to the labels on each axis. This is an example of, and again, it's going to be even more important to label your axes. This is an example of a kid going down a slide. So here's the kid going down the slide. Whee! Right? There's the cross section of the slide going down and then the ground, right? Watch out, there's a boy there. This is the distance from the ground. This is more position where, take a look at graph B, still representing the same situation. Just changing up the axes. Look at the speed. Think about the speed of this person. Speeding up, speeding up, speeding up, slowing down, slowing down, slowing down. Speeding up, speeding up, speeding up, slowing down, slowing down, slowing down. Right? If you change the axis, it will change what the graph looks like. It all depends on what you choose your axis to be. So for example here, a truck driver enters a street, drives at a constant speed, stops at a light, and then continues. There are really two different options that we could choose here. We could choose to do a distance versus time, or we could choose a speed versus time graph. It's really up to you. Let's take a look at the distance versus time. A truck driver enters a street, drives at a constant speed, stops at a light, distance stops going up, and then continues on. Everybody following me there? But what about his speed? Okay, well, the speed goes up. What's going to happen to his speed as he goes to the light? To zero, right? He stays at zero speed for a while, and then he accelerates. And then he probably drives at a constant speed. Hopefully he's not accelerating forever. Right? So depending upon the scenario, you might have a different graph. Okay. The second option here, a small bookstore sold between 5 and 8 books each day for 7 days. Where this one was continuous, this is discrete. Okay, between 5 and 8 books for 7 days. So here's 5, here's 8, here's day 1, 2, 3, 4, 5, 6, 7. There you go. There's an example. The reason why I present this one is because this is more discrete data rather than continuous data. Okay. And then we could have just come up with this possible situation for this graph. What do you think a situation could be for this graph? Go ahead.
Soapbox derby have a speed of the cars.
But wouldn't the speed go up as I go down the hill? Speed, right? Oh,
As the car runs out of gas.
okay, so he's slowing down, then he's trying to coast a little bit.
Yeah.
And then what happens?
Yeah.
I think about this. What happens if somebody gets pulled over? Like, oh shoot, I passed a police guy. I better slow down. Oh, I hope he doesn't see me. I hope he doesn't see me. Uh-oh, he saw me. I gotta slow down to a stop. Right? That's what I think. Okay. Again, the OST loves to give you examples like that of creating a scenario to fit a graph. Creating a scenario. Giving it a backstory. All right, everybody. Hopefully everybody's having a good day, and the folks at home, make sure you follow along. Make sure you stay up with your work. So long.